All right, CNT125, we're working on Chapter 10. We're going to work on the section on firewalls. Firewall is really just a specialized device. It's kind of like a router that's been beefed up with a lot more capabilities, is kind of an easy way to think of it. It selectively can filter and block traffic between networks, and usually involves some kind of hardware and software combination. And the firewall ends up being basically like your bouncer at the door checking IDs. That's the kind of the concept behind this. We can either put this between two different parts of our network, or two different parts of our own network, or most commonly between our network and a public network. Our network and a public network. Our company network and a public network, if you will. That's a common location for it, like here. Are all of our company resources here? Firewall is the last stop before traffic gets to the internet. We have network-based firewalls or host-based firewalls. Your network-based firewall is what a lot of people think of. This is the actual device that sits at the edge of our network. A typical appliance like a Cisco appliance, a Cisco ASA, that's what we're going to end up using. We have a handful of these to use for our lab, and it's really there to protect the whole network. That's the idea behind it. Meanwhile, a host, and actually here's an example of a network-based firewall. Here's another one. Ours are these guys right here. There's larger units handling more volume, more traffic, that sort of stuff. And it's usually sitting right here protecting the whole network, the whole, everything inside of that network. Meanwhile, there's also host-based firewalls. This is an application running on a host machine, a node, and it's designed just to protect that particular node, that particular device. Something like a Windows Defender firewall would be an example of that. We are going to, we're going to configure the Cisco ASA for our network. We're also going to configure the Windows Defender firewall, so you can see how that gets done too. And I just threw a picture of your Windows firewall here to remind you. And we're actually going to write a specific rule in here and add to this for ours as well. Your host-based firewall is really there to protect that particular node, and you might actually have a basic firewall running on everything, just as kind of a little check. There is different types of firewalls. There's packet filtering firewalls, there's stateless, stateful, etc. So let's take a look at some of those different types of firewalls. Sometimes you'll read the description of a firewall and it talks about what it is or what it does. Your packet filtering firewall is your simplest firewall. It's really just going to examine the traffic moving through. It's going to look at the header and say, what are you, where are you trying to go, and filter based on that information. So it's going to look at, hey, the IP address, where are you trying to go? Yeah, that's okay. It'll look at the TCP header, look at the port number, where are you trying to, what are you trying to connect to? Okay, that's all right, and away it goes. It can block traffic entering inbound or exiting outbound. This is very common on, what you have at home, your small office, home office router that you have at home, very common. Just kind of checking everything going in and out. The picture they used here for you in the book, they showed the inbound, outbound traffic. I put a couple balloons here, little call-outs to help you realize what they're talking about. If I have, here's my private LAN here, traffic coming inbound to the firewall, this right here, inbound rule for private LAN side, might deny FTP traffic, so I cannot send any data outside of my network. Meanwhile, over here, the inbound rule for internet side might deny telnet traffic coming in to my network. Okay, so and when we talked to ACLs earlier, use the security guard example. That helps you kind of sort out the inbound, outbound traffic thing. That can be confusing until you give it an example like I did with the security guard, which way they're going to check traffic. Your firewall default configuration blocks a lot of common threats, pre-configured to accept and deny certain types of traffic. Network administrators often take that and start adding to that. Even your firewall settings at home are basic. You might need to add to that or adjust that. Some of you know from having your firewall at home, I'm sitting here looking up at mine right now, right after you bought a certain type of game, whether it be for your desktop or Xbox or whatever, that traffic did not go through the firewall until you connected into the firewall and said, yes, this particular traffic, whether it be Call of Duty or whatever it is permitted through this firewall. And then actually what it did was allow that TCP port number through. Common packet filtering criteria. This is going to sound a lot like our ACLs. Source and destination IP. Where are you coming from? Where are you trying to go? Source and destination ports. Where are you coming from? Where are you trying to go? You're trying to telnet it into my server inside. Get out of here. Go away. You're coming from a valid IP outside, trying to SSH to my server inside. Okay, because that is a remote connection we're allowing to occur. Flags are set in the TCP header. Certain types of flag fields are permitted or denied. Certain protocol ports are permitted or denied, etc. So there's some different criteria that can be filtered, very much like our access lists. They give you some common packet filtering firewall criteria examples, and this is kind of leans right back on the access list we talked about before. If you're trying to connect from a network it doesn't recognize, no, go away. I could block or deny certain insecure ports, and they give you NetBIOS example, but I could be even blocking Telnet, that sort of thing. So between the two, I could say, okay, if you're coming from a certain network, you're allowed. If you're trying to go here, you're denied. So between the two, if a hacker even spoofs your IP, but is still trying to get to NetBIOS, between those two rules, we're still stopping that particular attack. I do have to be careful as I'm dealing with ports of what I'm blocking. I need to make sure I'm allowing things like 80 through, 443 through, but I got to be careful I don't block things. Maybe 22, I might be thinking, blah blah, but 22 might be my SSH for a remote connection. So I might need to be careful and allow that, but I might spell that out further and say 22 is allowed if it's coming from here going to here. Anything else, go away. And that's what I give you an example out here. I might need to spell that out as where it's coming from, where it's going to. Optional firewall functions have additional features. It can do encryption. It can actually do user authentication for somebody remotely connecting. I can do central management through almost like a browsing interface. And from that, I can even do sometimes some easy rule management. I can do some clicking and applying, and it makes the rules for me. I don't have to write all those ACLs out like we did before. I can do content filtering based on highest level. I can actually do it based on content. What are you trying to bring in here? What kind of traffic are you trying to bring in? No. That's questionable data for our company. I can actually do some logging and auditing. I can actually monitor packets as they're moving through and streams. So these are some additional things that firewalls can do for me in some scenarios. So that brings us to other types of firewalls, stateful and stateless. Stateless, let's start with this one. A lot of times this is what we end up dealing with. Stateless is every packet that comes in, it picks it up and examines it and deals with it. So almost like a security guard coming in. Hey, who are you? Where's your ID? Okay, great. Hey, who are you? What's your ID? Okay, great. And it really doesn't care if you're with, hey, I'm with these guys back here. Don't care. I'm looking at your ID. Okay, as long as your ID is okay, go ahead. And it literally deals with every single chunk of data individually. It is actually faster, but it's not very sophisticated because I'm not factoring anything else in other than just looking at that packet. A stateful actually looks at that information, but it goes, hey, is this part of some other conversation that's going on? Is this okay? Then it should be legit. If not, what are you doing here? Why are you here? Okay, so this tends to be a little bit more slower, but it is actually more sophisticated. So they do have stateful and stateless firewalls as well. Your router at home typically acts like has a firewall built into it, and it basically includes the packet filtering options, almost like a stateless firewall. That's typically what you have at home. There are other devices out there, Cisco and so forth, enterprise known, that have a lot more features like we just got done talking about, in addition to your packet filtering. It can also be, instead of a hardware device, it can actually be a software. Firewalls can actually be a software running on something. Things like IP tables, zone alarm, etc., Windows Defender Firewall, etc. These can be running to do the same kind of functions. Look at the packet, where are you coming from, where are you going, what are you trying to do? There is also a trend, unified threat management, where it's going to combine entities like our firewalls, network hosts, etc., along with some other things that we're going to talk about soon, to make a bigger, almost like a bigger organized look at traffic coming and going, unified threat management. So instead of having all these little individual entities working together, this tries to combine them, saying, hey, let me factor all this together to say, yes, you can, no, you can't. So you might see unified threat management with certain devices, meaning it's going to try to combine data from other things to make decisions. Your NGFW, next generation firewall, you see these two. These can, again, firewalls can analyze data at higher layers, application layer, user aware, adapt to different types of users. What are you? Adapt to different types of applications. You know, hey, this IP traffic is for phones. We're going to let that through a little bit better. This we're going to examine a little bit deeper, etc. So you have some next generation firewalls too that are starting to be a lot more aware and functional. And here we have some ASAs that are next generation firewalls. The most common cause of firewall failure is misconfiguration. And it does take, you're not going to turn it on and have it ready to rock and roll the first time. It's going to take tweaking and tuning over time, days and weeks, to get all of the permitted traffic through correctly and the denied traffic to stopped as necessary. It needs to be strict, but it can't be too strict. So there has to be a balancing game, and that's why it's typically done over days and weeks to tweak and adjust and ooh, I made it too strong, back it up. But it takes time to tune that, and it kind of takes updating frequently to keep it working well. Any sort of exception I put through the firewall, they use the term punching a hole. We need to punch a hole through the firewall for blah device or blah thing. All right, we'll come back in the next one and talk about the next category of equipment.